everyone, welcome back. It's great to have you here today. In this video, we are going to go through 5 EMC style questions. I recommend trying these questions yourself first. You can find the link to the question in the description box. If you need to review the content before attempting these questions, this playlist might also be useful. Okay, so now let's get started on the first question. So in this question, we are given two shapes. And for the cylinder, we are told that the radius of the base is x and the height is 2x. We are also given a cone and we are told that the base radius is also x and the height is h. We are then told that the volume of these two shapes are equal and we need to find an expression for h. And we are told to leave the final answer in the simplest form. Since we're told that the volumes are equal, so we need to work out the volume of each shape. So first step we are going to do is to work out the volume of the cylinder. And just to remind ourselves, the volume of cylinder is pi r squared h. And we know what is r, which is x, and the h is 2x. Therefore, to simplify, we have 2x cubed pi as our volume for the cylinder. And similarly, we're going to do the same for the cone. And the volume of the cone is a third pi r squared h. So we know what is r, which is x, h, leave it as it is. This is something we need to find. So in the end, we have a third x squared h pi. And because we know the volumes are equal, therefore, we can set up an equation and simplify. So we can divide both sides by pi by x squared. And then we have 2x is a third h. To work out h, I multiply both sides by 3. Therefore, h is 6x. And that is the answer for the first question. Now moving on to the second question, it's very similar. We are given two shapes. One is a cylinder, the other is a sphere. The radius of this cylinder is 2x and the height is h. And we are told that the radius of the sphere is 3x. And again, the volume of these two shapes are equal. So what we need to do is to work out their volumes separately and then set them equal to each other. So the volume of cylinder, pi r squared h. Simplifying, we have 4x squared h pi. The volume of a sphere is 4 over 3 pi r cubed. So r is 3x in this case. Simplifying, we have 36x cubed pi. And then since they are equal, I'm going to set them equal to each other and solve for h. So make h the subject. We can work out that h is 9x and that is our final answer. Okay, so now moving on to the next one. So in this question, we are given two solids, a cube and also a sphere. And this time, we are also given the dimension. So the length of the cube is x and the radius of the sphere is 3. And what we need to do is to work out the surface area because we are told that the surface area are equal. So the surface area of a cube is simply 6x squared. There are 6 sides and then each side has an area of x squared. The area of the sphere, we are given the formula 4 pi r squared and because r is 3. So the area for the sphere is 36 pi. And then because the surface area are equal, so I'm going to set these two equal to each other. Dividing both sides by 6, we have x squared is 6 pi. Now if a number is being squared, it can be positive or negative. So that means x can be positive or negative square root of 6 pi. But because x is the length, it cannot be negative. So in this case, x is square root of 6 pi. And that is our final answer. Okay, now moving on to the next one. The first part of the question is easy. In this case, we are given the cone and we are told the dimension. The vertical height is 8 centimeters and the radius is 5 centimeters. And now we are asked to work out the volume of this cone. Now using the formula, a third pi r squared h, we can work out that the volume is 200 over 3 pi, which is 209 to 3 SF. Okay, now moving on to the second part. Now this question is slightly harder. So what we need to do is first, we need to be able to make a cone out of this major sector. So I'm going to draw a cone just to show you what it would look like. We are told that the slant height is 15. And now we need to work out the vertical height. First, by looking at this question, you might feel like you don't have enough information because you know the slant height, the base radius, and the vertical height is a right angle triangle. Therefore, you need to use Pythagoras theorem for this. But we are only given the slant height. We are not told the base radius. So what can we do to work it out? The arc length in the first sector, it is the same as the circumference of our base in the cone. Okay, so let's work out the arc length first. We know know that is 216 degree out of 360. So that is the proportion of the circle I want. To work out the circumference, the formula is 2 pi r or pi d. So we needed to do 216 over 360 times by 2 pi, and r is 15 in this case. So we know the circumference of the base of the cone is 18 pi. Now by looking at the base of the cone, we know the circumference is 18 pi. We know to work it out, we need to do 2 pi r. So that tells us the radius of the base is going to be 9. So now we need to work out the vertical height. I'm going to sketch out another triangle just to make it clear. We have the base radius, which is 9. We have slant height, which is 15. Work out the vertical height. We need to use Pythagoras theorem. Square root of 15 squared, take away 9 squared, and that is 12. So 12 is our final answer. Okay, so now moving on to the final question. This question is very interesting and it is harder. So what we need to do is to break it down. We can see two hexagons here. So I'm going to draw two hexagons out just to make the question a bit easier. The side of the smaller hexagon is x, and because it's regular, it means that all sides are equal and all the interior angles are equal. And we are also told the scale factor is p. So then that means area scale factor is going to be p squared. Try to work out the area of the smaller hexagon, because once we work out the area of smaller hexagon, multiply that by area scale factor will give us the area of the larger hexagon, and then we can work out the difference between them to work out the shaded area. So let's have a look. We can divide this hexagon into 4 smaller triangles and 1 big rectangle in the middle. Now we know if we draw a perpendicular line, we will be able to work out the angle are 30, 60, and 90. How did I know that? Interior angle of any regular polygon is n take away 2 times by 180 divided by n. In this case, n is 6. So I can work out one interior angle is 120. So dividing them into 2 equal parts, I'll have 60 degree. And we can use trigonometries to work out the length. So what I'm going to do here, I'm going to sketch out a right angle triangle and label what I know. So if I use that 60-degree angle, I know that x is my h. And to work out the opposite, I do h times sine 60, which is the opposite. Sine 60 is a special angle we need to know is root 3 over 2. Therefore, opposite is root 3 over 2x. And to work out the adjacent, I need to do h times cos 60. And cos 60 is also a special angle we need to know, which is a half. So a is a half x. To work out the area of this hexagon, I'm going to draw the shapes out and label them with what we just worked out. So the area of the rectangle is easier. We can do base times height, which is x times by root 3x, and that gives us root 3x squared. Now to work out the triangles, I can do a half times base, which is root 3x, times by height, which is a half x, and that gives us root 3 over 4x squared. Now in this shape, I have 2 such triangles. So to work out the total area, I will add all of them together and simplify it. That gives us 3 root x over 2x squared. The area of the smaller hexagon we have worked out, 3 root 3 over 2x squared. And then the area scale factor is p squared. Therefore, the area of a larger hexagon is going to be 3 root 3 over 2x squared p squared. But we haven't finished because we need to work out the shaded area. So to work out that, we need to do the area of a large hexagon, take away the area of a smaller hexagon, and then we need to factorize out the common factors, which is 3 root 3 over 2x squared, and in the bracket we'll have p squared subtract 1, and that is the same as our final answer given in the question. That is it for today. Well done for making through to the end, especially if you have done the questions yourself. Remember, maths isn't a spectator sport. You have to keep practicing to be more fluent. Happy revising, and I'll see you in the next video.